Hi, everyone, and welcome back to Data-Driven Problem Solving. We already talked about using existing data, and last week we talked about creating new data using things like surveys, interviews, and other methods. But what if you need to go further than just having data, and you want to see if there's a cause and effect relationship or test whether something's really happening between things? That's where experimentation and testing come in. So let's get into our items today. Number one, why experiment? Well, sometimes our questions haven't been asked before, and experiments can give us a direct answer. And sometimes we might have a gut feeling about how to improve something, and testing can help us know for sure. Imagine you're working for a company that wants to improve their website, and you have this awesome idea for how to change the page that no one's ever done before. You think it could really boost sales, but how can you know for sure? Well, if you did an experiment that let you test your idea in a controlled way compared to the old website, then you could get data that tells you if your idea actually works. Experiments can be thought of as more or less experimental in nature. The most pure is what we might call a controlled experiment. These are the gold standard if you have the time and resources to do them. In a controlled experiment, you control all the variables and compare groups, say a treatment group that experiences the change you're testing and a control group that doesn't. This then allows you to isolate the effect of your change to see what outcomes it produces. But oftentimes in a real world business setting, you may not be able to control everything. For example, maybe you can control what automated marketing people see after purchasing your products, but you can't control which of your customers choose to buy product A versus product B. When you're limited in the control, then it's often called a quasi experiment because you can only quasi control the different variables happening, but you can still gather valuable insights and make some more assumptions based on the data. When you can't control any aspect, well, that's just analyzing data. And that's wonderful. Those are still probably extremely useful analyses. They just would be considered non-experimental research. For example, maybe you discover a correlation between social media mentions and website traffic. But that doesn't necessarily mean that one of those things caused the other. All right, before you begin your experiment, you're going to need to create a clear and focused statement called a hypothesis. This is just a prediction of what you expect. When you're creating a hypothesis for an experiment, you actually create two hypotheses. One is the hypothesis, sometimes called the alternate hypothesis, like shown with an H and then a little a. Sometimes they're numbered like H1 or hypothesis 1. But your main hypothesis is really your prediction, the thing that says, I think there's a relationship or a difference here. But you also create the second hypothesis, which is called the null hypothesis, sometimes called H aught or H with a little zero. But the null hypothesis really is just stating that there's no relationship between the things you're testing at all. By the end of an experiment, your aim is to either reject the null hypothesis, meaning your prediction could possibly be supported, or fail to reject the null hypothesis, meaning your idea may not be supported and maybe you need to refine your approach further. When you're crafting your hypotheses, make sure that you have one that's testable. Ask yourself, can I realistically gather data to prove or disprove this? Be clear on exactly what you're measuring. You need to be specific and not leaving anything ambiguous about how you'll track it. And you'll want it to be discrete. What I mean by that is you should focus on a specific change or relationship that you want to investigate. Because if you try to test too many things at once, it can tend to muddy the results. So in today's digital world, I would say that A/B testing might be one of the most popular business experiments that you see out there, especially because of how easy it is to do in online settings. Here's how an A/B test might work. You create two versions of something, like a web page, and then you split the audience. Have your users see version A and the other half see version B. Then you track which version performs better over time based on whatever your goals are. Maybe that's generating more sales or getting more clicks. Once you have that data, you can analyze it and decide if one version generates better business results for you than the other one. A/B testing is awesome for comparing two options in sort of a head-to-head competition. But there's also multivariate tests if you need to test more than one variable at once. When you're doing these business experiments and these tests, just remember that even the best experiments can be skewed by hidden biases. You're going to want to ensure that your findings are reliable, and here's some things that I think can help you do that. If possible, blind the people involved in the experiment. What this means is try to keep both the participants and the researchers from knowing which group of people are getting which variation or option. And that's going to help because it's going to reduce the chance of unconscious bias that might be influencing the behavior of the participants or the interpretation of the results by the researcher. I also recommend randomly assigning participants to groups whenever possible. This can help control for pre-existing differences between groups, the kinds of things that maybe you might not realize, but could really influence the outcome. Clearly define your success metrics before the experiment begins. This can help you from accidentally cherry-picking data that supports your initial hunch and can help ensure that you're measuring what really matters. And you want to be aware of this thing called peaking, especially in online experiments. What this just means is try to resist the urge to constantly check your results. They tend to fluctuate quite a bit over time, and you want to let the experiment run its course to avoid making any conclusions that may have more to do with fluctuation than your actual findings. All right, those are our 5 key takeaways, but remember, don't think of them in isolation. We've had lots of good stuff that we talked about in prior videos that are still applicable here. Before you jump into testing, you need a research plan, and you want to keep paying attention to things like sampling or keeping your eye out for other factors that might influence your findings. I'd love it if you left a comment below if you have any tips for using business experiments to solve problems, and I'll see you in our next video where we're going to get into the task of how do we analyze qualitative data. I'll see you then.